January 28th, 2020. Oh, nothing good ever comes easy, does it? So, the Raspberry Pi 4, and as far as I can tell, also the Pi 3, although I have not been back to read up on that specifically because I'm working on the 4, says that it needs 5 volts to run, and yet, when you get the CanaKit power adapter and plug it in and hook it to the Pi, everything works fine. But if you take it off of that and you put a 5 volt supply in that is exactly 5 volts coming in, it will show low voltage, and it will maintain that low voltage indicator continuously. For those who don't know, that's a little lightning bolt in the upper right hand corner of the screen, and you'll see that throughout usage when voltage is low. So after much research on the net and a lot of looking into Raspberry Pi forums and reading other people's assessments of things and doing some voltage readings of my own, come to find out the Pi 4 actually wants about 5.1 to 5.25 volts. So I have a fixed DC to DC voltage converter here. This takes the 12 volts, or roughly 12 volts, like at the moment it's 12.81, of my solar power system that supplies power for the pumps, the Raspberry Pi, the vents, all that sort of stuff. Takes that 12 volt feed and turns it into 5 volts, and then that feeds the 5 volt side of things. Well, obviously if it's fixed and it puts out 5 volts and I need 5.1 to 5.25 volts, I'm going to have a low voltage issue continuously with the Raspberry Pi 4 if I don't address it. And since I have no way to adjust it, I called up my friend Aaron because I was looking at buck converters and I wasn't sure how stable or good they would be. And he suggested this one here, which is it was about $9, $10 I think. It was $10 shipped. And it basically takes in, I think it's like, it'll take like 10 to 24 volts. Yeah, so for those who wanted to get one of these converters, I just pulled the package back out, and it's 12 volts to 5 volts, 5 amps. So it doesn't go up to 24 like I thought, but that doesn't matter for me. So it's a 12 volt to 5 volt converter, 5 amps, so that'll run the Pi Plus. Also, I'm going to have an Arduino on here. It'll also cover that for power. And this is made by DROK, and I got it on Amazon, and you can see the part number there. So if you decide you need to get one of these, you can find it. Like that in, and it'll put out about 5.2 volts continuous. It also has a USB connector so you can charge stuff. Kind of handy, I guess, although I've got USB connectors for charging all over the shop, so that's kind of unnecessary. But anyway, for $10 I got one that's supposed to be about 5.2 volts. I'm going to wire this in to feed power for the Pi, and we'll see if that's enough voltage to keep stable voltage, because up until now in this testing mode I've had the Pi plugged in on the CanaKit brick, and in order to adapt for the new USB-C connector and to make sure that I had a robust enough cable to carry the current without voltage issues, or at least I thought, I actually bought another one of those bricks, and I just cut the transformer part off and used the cable and wired into the existing 5 volt inverter. But still, at 5 volts we don't have enough voltage. We need 5.2 for the Pi 4 to run. So heads up to anyone who's designing a DC based Pi 4, if you get a voltage converter to go to 5 volts exactly, it won't be enough. You'll need to find a voltage converter that will do 5.1 to 5.25 volts, and it should be capable of 3.5 amps if you're supporting a Pi 4. Alright, I just kind of wanted to do a preface on this before I do the install. I'm going to install this sometime, probably tonight, and test it, and hopefully this will solve the voltage issue and we can get switched over entirely to solar DC power, as that was part of the main intent of this greenhouse in our testing scenario. Yeah, I think that's everything I wanted to cover for now. So, hang on to your shirt. It'll be a lot shorter for you than it will for me. Catch you in the next clip. Okay, test one. This speaker that I use for audio here in the greenhouse has a barrel jack on it, and this adapter came with the barrel jack, so that's kind of nice. This tests out at 5.09 volts so far. So I think that'll be enough, but I'm a little nervous, I gotta say. So before I go wiring anything else in to do that, I think I'm just going to pull the USB-C connector over, put it onto the terminals, and test this and see if this is enough voltage before I get all crazy wiring something in that ultimately may not work. Anyway, it lights up, it seems to be regulating voltage, and the barrel jack works. So that's a good start. 5.09 isn't my favorite, but we'll see what it does under a load too. It may change a bit under load. Alright, catch you in the next clip. Alright, here we go. It's powered in from the jack. It's wired into the USB-C adapter that comes into the power switch right there. It goes into the power. Moment of truth right now. Ooh, so far so good. So far so good. Alright, now we'll permanently wire a power feed to it and figure out where and how to mount it. I'm going to stick a voltage meter on it quick now that we're up and running and see. But hey, that's good news. So thanks, Aaron. Looking good so far. Okay, so here we are with the relay fired. All of that stuff is running off of that power converter. The pump on. Got a browser open to make sure that basically the Pi is under a reasonable load. Got a couple of probes tapped in on the output here. And look at that. We're sitting right in the sweet spot. 5.12 volts. And that's right inside that 5.1 to 5.25 voltage window. And we're not getting any low voltage errors or issues. So that's fantastic. Alrighty. So I hope if you have a Raspberry Pi 4 and you're trying to get it to run on a DC power source, I hope this helps you, because 5.00 volts will not do the job. You need 5.1 volts. And you got to stay in that window of 5.1 to 5.25. You start to exceed the 5.25, then you run into dangerous voltage issues and you risk damaging the Pi. Okay, lucked out in my Pi box. I had one of these barrel connectors, so that made this easy. And I had a couple of a spade and a terminal connector. So this is my ground bus over here. 12 volt power in here, fused off the fuse box, and then that feeds the barrel connector to the 12 volt 5 amp 5 volt converter, putting out 5.1 volts. Goes right into, on those terminals on the bottom right there, into the USB-C cable, which comes through into the Pi box right here, plugs into the power switch, and plugs into the board as normal. So all our power's coming through there now that we're on a clean Pi 4. I was having voltage issues for a while on the Pi 3. This probably was the real cause of it, was the lack of excess voltage needed. A lack of excess, yeah. So I had backfed 5 volt power in off the converter into the Pi Easy Connect board just to make sure we had plenty. And of course I was still having voltage issues, so I'm quite certain that the Pi 3 issue was also, it really needs 5.1 to 5.25. Anyway, it's all wired in. This is my first fire up with a new wired in system. Let's see how she does. We're booting. I'll kill my headlight so you're not getting all kinds of glare right there. And for reference, we had good sun today, so we're sitting at 12.67 volts on the bank. It looks like we're drawing about 8 watts or so in general. Not sure that watt meter is entirely correct these days. It seems to show a static 3 watts being burned even when there's nothing powered on or connected. Well, look at that, no low voltage issues. Yeah, looks like it came up okay. Let's just load some programs, like say, let's load Kdenlive and a browser. Put the processor and machine under a good load. There's Firefox. We'll restore the previous session. That was at 1080p. And then Kdenlive is loading over top of that. That's a Linux-based video editor. That popped up. I don't have any videos to really test this to the max with, but seems to be working good. No low voltage issues, no sluggishness like we had with low voltage issues. I'm going to call it a win for now. Alright, just wanted to do one quick follow-up. I ended up soldering the terminals on the board because the screw terminals weren't holding too well, so I just soldered directly. I also have a second power feed that comes off to run the 5-volt relay board to feed power to that, so those relays can be tripped. And I cleaned up the box here where I had all those other power leads coming in. Sorry for the lighting. So you can see there's a whole lot less rat nest in there, and man does that feel better. I removed all the excess leads and all the power jump overs and all that stuff. And so we're sitting here static at 3.807 watts without the relay board and without the Pi powered on. I'm going to plug the power converter in. So far we're not seeing a difference in power. Wouldn't expect we would. And then now we're going to turn this on. Remember, we were at 3.08 watts. Now we're showing 7.6 during the display test post. And then now as it starts to load the OS, we just spiked at 10 watts for a second there. And we're sitting around 8 in general. Loading the Raspberry Pi screen. I apologize for the glare from the headlight off the monitor. Oh, we're at 10 again. And then the desktop is loaded. And so we're sitting back around 8.8. So let's see if that's accurate, then we're 8.8 watts. I think that would make sense for the Raspberry Pi 4. But if that 3.8 watts that it's either incorrectly reporting or whatever is a factor, then we're sitting around 5 watts. So somewhere between 5 and 8 watts, just sitting on the desktop, which is not bad. I'll fire up the browser here. We'll see. Yeah, that goes up to 10 there, loading the browser. 11. And back down to 10, back to 8, back back to 10 as the browser loads the page. So it looks like it draws around 10 or 11 watts continuous when it's running. So I just wanted to follow up and give you that power information, just for reference. And of course that's the Pi, and it's also keeping the relay board fired up. I doubt that's more than a couple milliamps just to keep the board up. None of those relays are picked at the moment. And actually, I have to turn the thermosiphon pump on anyway, so let me just do that quick. We'll pick that relay. You can see the power's on. And wow, I'm not hearing all the noise coming back that I was before. Oh, I have the speaker off. Don't mind me, I got a lot of things going on here. So with the pump on, we're drawing around 14 or 15 watts continuous. I'd say probably 14 and a half continuous. So that is that. I hope this helps, and that's all for now. So I recommend, if you're running a Pi 3 or 4, that you run a voltage converter that gives you 5.1 to 5.25, and then you won't have continuous low voltage issues. If you go through the Raspberry Pi forums and look in low voltage issues, low voltage indicators, you will see that over and over and over. And some people legitimately have bad wiring and bad power distribution systems, but a lot of times I think it comes back to, they say it only needs 5 volts, but it really needs 5.1. Hope you found this informative or interesting. Thanks for watching the Pharmacy Seeds Network. Hope you'll tune in for our next video. Don't forget to like and subscribe if that's your thing. You know how to hit the bell. Thanks for watching.